I think we have
Yep.
for
Yep.
for anyone that also wants to join, right after this, we're doing the monthly Stacks Miner call, which is another public call. I put it out on Twitter, but I can probably grab the link at some point and share it if anyone wants to join. Jude Nelson will be with me on it. We'll be going over a bunch of stuff with mining and the 2.1 upgrade and all that stuff. But cool. I guess let's get it started.
Yep.
Awesome. Well, first of all, thank you so much, everyone, for kind of having me. I really like doing these kind of presentations, especially with the community. It's it's kind of a fun way to spread the knowledge around. So yeah, I'll give a little presentation here, and then if we have some time at the end for Q&A, I'm happy to do some of that as well. But yeah, let's get it started. So this presentation is going to be all around proof of transfer, how proof of transfer works, the kind of philosophy and design architecture behind it, and kind of what it can enable is kind of a new primitive on top of Bitcoin. So quickly, just some background on myself. I joined the Stacks core team back in kind of early 2017 as one of the first non-engineers. My focus the first 2 to 3 years was on growing and scaling the developer ecosystems. For Stacks first, mostly focused in the Americas and Europe. And then in 2019, I started going out to Asia a lot to do the same. I ended up moving to Hong Kong in 2020, left the core team and started my own company on top of the Stacks network. So that company is called Daemon Technologies, like a Linux daemon. We have a pretty wide goal of spreading the adoption of Stacks technology in Asia. But our kind of more specific focuses over the last couple of years, one has very much been on the mining side of things. So we are one of the main Stacks miners, or I guess one of the more consistent Stacks miners. We create some tools, data products for other miners as well. OnStacks.com is the main product we've created there. And then we also do a bunch of funding and partnerships for the ecosystem as well. So before we kind of dive into proof of transfer, I like to kind of give a high level view of how we think about system design with Stacks. And the reason that Stacks is built the way it is, because it's quite a bit different from other networks in the space. So Stacks is a blockchain-based network that is kind of anchored to Bitcoin and provides composability and scalability on top of Bitcoin. What we mean by that is composability is the ability to extend Bitcoin into more products and services, do enable things like smart contracts, which then can, really power a world of DeFi and Web3, and all the cool stuff and what I consider really meaningful innovation that we've seen over the past few years in some other parts of the space, Ethereum and some of the other networks, but where ultimately it settles down to Bitcoin, and we use Bitcoin as kind of this ultimate settlement and security layer. And the reason that we do this is, why is Bitcoin important? People talk a lot about, oh, Bitcoin's a store of value, it's digital gold. And I think someone needs to just mute themselves. Michael, if you don't mind muting yourself. Thank you.
All right, sorry.
Still hearing a lot of background noise.
Yeah, I'm trying to.
Okay, there we go. Cool. So as I was saying, a lot of people talk about how Bitcoin's a store of value and how it's digital gold. And I think these are good framings for use cases that Bitcoin can serve. But to me, they don't actually get at the heart of what Bitcoin is as a network. So as a network, it doesn't do anything on the network level that is a store of value or digital gold. These are kind of use cases of what the Bitcoin network provides. And to me, the framing that really hammers home is that Bitcoin is a trust machine. Bitcoin is the only thing in the world that exists and that I think really has ever existed on a global scale, where no matter who you are, Republicans or Democrats, North Koreans and South Koreans, pick any two groups that are as diametrically opposed to each other as you can be. They all agree on the Bitcoin network. And every 10 minutes, roughly, the Bitcoin network spits out the most secure cryptographic proof of that agreement. To me, that's really the heart of what Bitcoin does. And that's how we leverage it. We leverage it as this global settlement of trust. And the reason that that's important is, you can have these fancier things like DeFi or, generally Web3, but ultimately, if the activity that you're doing, in the DeFi space, whether it's, taking out collateralized loans via, something like Alex or Arcadico, or, doing anything fancier, at the most basic level, if you can't actually trust in the stack that you're doing that on top of, it really defeats the entire purpose and the use case there, and kind of just gets us back into the world we exist in today. And what Bitcoin actually provides, to kind of use a slightly more technical term, is it provides Byzantine fault-tolerant consensus at a global scale, which is how in a adversarial environment, which is the kind of open global world by definition, how do you create a mechanism where every participant in that system can kind of come to agreement and make progress? And that's the question that Bitcoin kind of answers. And also, what's important too, and kind of the philosophy behind the system design of stacks, is that primitive, that Byzantine fault-tolerant consensus, is somewhat of a binary feature. And I think this is something that, felt a bit more contrarian to talk about a few months ago than it does today, with everything that's happened over the past few months, whether it's the Ukraine war, the last week with Terra. A lot of networks have kind of taken the design decision, and I think, we'll get into this, but Ethereum is a good example of, let's take a single layer, single network, and let's try to make it as feature rich as possible while kind of maintaining this idea of BFT consensus. And, ultimately, we don't believe that that's really a trade-off you can make at the lowest level. The lowest level needs to focus on that and nothing more. And not only that, but more importantly, if you look at every kind of globally deployed distributed system at scale today, and my favorite example of this is the internet, no existing real world example at scale has been architected in a way where, they've taken a single layer and they've tried to expand it to serve as many use cases as possible. With the internet, you don't take the HTTP protocol and try and, cram everything else into it, whether it's, TCP IP or what else. Rather, you layer these protocols and networks on top of each other in such a way that they work together to ultimately deliver the end user experience, which is the internet as we have it, through a browser. And this is really kind of how we look at the Stacks network. Now, the problem with Bitcoin, just Bitcoin, it's not a problem with Bitcoin, it's kind of a feature. But when it comes to enabling Web3 or DeFi that settles ultimately on the Bitcoin network in some way, you don't want to change Bitcoin. And you can't do expressive smart contracts on top of Bitcoin, rich composability, as well as transaction scalability. The Lightning Network is a great example of that too. I'm a huge fan of Lightning. I've known, I've had the privilege of working with Elizabeth Stark and some of her team in the past on that. And I look at Lightning as complementary to us. We're both looking at Bitcoin and saying, we don't want to change Bitcoin, but how can we layer, protocols or systems on top of it that ultimately settle down to it such that we can, increase scalability, add new feature sets. And so, with the Stacks network, the question was, how can we create highly composable Bitcoin-based use cases without changing Bitcoin? To kind of hammer this home, this is kind of a visual of how we think about it. Ethereum tries to create full expressiveness and BFT consensus on its layer 1. And then it tries to use the layer 2 to kind of solve scalability issues there or deal with specific use cases. We have Bitcoin at the lowest layer, and we focus on extending expressibility above that in new protocols. So the way we do this, and to get into proof of transfer itself, I think of proof of transfer conceptually is the same as proof of work. The details are a bit different, but conceptually it's the same type, it's the same rough category of consensus mechanisms versus something like proof of stake. Miners are the ones who secure the network. They validate transactions and are incentivized to do so by participants on the network. And in order to do that, they have to spend a resource of known value in order to compete to mint a new digital asset. In the case of Bitcoin or any proof of work chain, that scarce resource that miners have to spend is electricity. With proof of transfer, the kind of aha moment we had is you only have to go from electricity to digital asset once. And so with proof of transfer, miners spend Bitcoin itself as the resource of known value in order to compete to win the next Stacks block and mint more Stacks tokens. Miners actually spend this Bitcoin, whether they win it or not. It's not staked or anything like that. And to quickly run through kind of the full mechanism, miners spend Bitcoin to compete for blocks. The act of spending Bitcoin is a Bitcoin transaction on the network, on the Bitcoin network. This is why the Stacks network can settle down to Bitcoin and how proof of transfer connects the Stacks network to the Bitcoin network, because every mining transaction, every block that is mined on the Stacks network, a hash of that block gets included in a Bitcoin block by Bitcoin miners. And so for any transaction or activity on the Stacks network that you do or you have, you can trace that down to a Bitcoin anchor block where a hash of the Stacks block of that transaction is included. Now, miners spend that Bitcoin. A neat feature of proof of transfer, which is kind of a nice to have and an incentive mechanism, it does not secure the network itself, is stacking. So the Bitcoin that miners are spending is forwarded on to Stacks token holders who are locking up their tokens and helping keep miners honest by signaling support for the longest chain tip. This is relevant in the case of where you would have potentially contentious forks of the network. And stackers kind of help keep miners honest by creating a disincentive to create a contentious, potentially malicious fork of the network. And so this diagram kind of shows that cycle. To get into a little bit deeper of a dive on how mining actually works in terms of probability to win and expenditure. So miners spend some amount of Stacks tokens, miners spend some amount of Bitcoin per block to compete to mint the new Stacks block. The amount that miners spend per block determines their probability of winning the next stacks block. You can think of this conceptually as the same as the more electricity that you can spend on trying to mine Bitcoin, or the more powerful machines you have, the higher your likelihood of winning the next Bitcoin block. But it is a game of, it's a numbers game. You need to mine long enough for that probability to play out. So in the case of stacks miners, the amount of Bitcoin they spend determines that probability of them winning a block. The amount that each miner spends is combined with a verifiable random function, which is on chain. And so to give an example, if, there are two miners on the network, I'm one of them, and I'm spending, 0.7 BTC per stacks block, and the one other miner is spending 0.3 BTC per stacks block, I have a 70% chance of winning the next stacks block, or stacks blocks in general, while that situation holds constant. But that's an overall probability. Just like flipping a coin, the expected value that I will see from mining is, 70% times the block reward times the number of blocks that I mine for. But again, like flipping a coin, you can flip a coin and, have 50 heads in a row. Like that is very improbable, but it can happen. The point is, if you mine for long enough, that probability will eventually play out. The way the rest of mining works is pretty simple. Once a winning miner is selected by the protocol, that miner earns the right to append the block to the stacks chain and earn the rewards. Now, the stacks chain has the same block time roughly as the Bitcoin chain. One of the ways that we kind of increase transaction throughput on the stacks chain is this idea of micro blocks, which is that the winning miner, the miner who won the last block, has the right to, between that block and the next block, stream what's called kind of micro blocks and commit them to the next block, in addition to kind of the winning miner. This is actually out of date and I need to update this. Sorry, I missed that. But this is an old view of what we used to have for the mining monitor, which is now on stacks. I'll actually get out of the presentation for 1 second, and I will show all of you what this looks like now. So this is on stacks. We have our own version of the Explorer. And we also have our own version of the mining monitor. So this is the mining monitor. It gives live data on the current mining market, how much miners are spending, how many miners there are, how much Bitcoin miners have spent all time. And one thing that I think is really cool too, and kind of speaks to how stacks can add value back to Bitcoin, is this number of total Bitcoin fees from miners. What this is referring to is, since the act of mining on stacks is sending a Bitcoin transaction, in order to mine stacks blocks, stacks miners have to pay Bitcoin miners to include their transaction and do so in a timely manner. And this adds value and more competition for block space in the Bitcoin network. As a result, to date, stacks miners have spent, I think if you do the math on the number of sats that is, it's 112.5 Bitcoins just in fees to the Bitcoin network since the stacks network started. Going back to this. Now, on the other side of this, stackers, as I was mentioning, lock their stacks tokens for one or multiple cycles. Stacking happens on roughly a 2-week cycle, but it's a 2,100 block cycle. depending on how many stacks you have to lock, you can either do so independently or through a pool. And again, stackers are helping keep miners honest by signaling support for the longest chain tip. And for that service, they are forwarded the Bitcoin that miners are spending themselves. I also, as an aside, love this feature. And it's a pretty interesting, unique funding mechanism because, well, on a personal level, I'm obviously biased and a big believer in stacks, but the stacks holdings that I can accumulate, they give me some potential future upside on being able to do Web3, but where it settles down to Bitcoin. But at the same time, it allows me to feel a little more secure in kind of holding on and working towards that ideal, because while I'm doing so, I'm just generating Bitcoin. And if you can do it on your own, if you have enough stacks tokens, you can actually earn Bitcoin censorship resistantly and kind of permissionlessly. One thing, I'll take questions at the end, but one thing that I want to kind of take right now, because I see it's a question, it's a good one. So if some millionaire comes and puts in a huge amount of Bitcoin, is he going to have the highest chance and would be getting most of the block rewards? So it's spending over time, because again, this is a game of large numbers. So I could come in and I could start spending a Bitcoin per block, and maybe I have a 90% chance of winning those blocks, but I'm going to need billions of dollars of Bitcoin to keep that up for even a day. There's 144 stacks blocks per day. You can do the math on the amount of Bitcoin that would be needed to do that. In addition, the probability doesn't just depend on the amount of Bitcoin I spend on a single block. The actual nuance of the probability is it looks at the last 6 blocks that a miner has participated in, and it calculates the probability based on the min of the median of the last 6 blocks. So basically, if I start mining for the first 1 or 2 blocks, I functionally have 0% chance of winning, because I need to build up a record of spending for stacks blocks before I can start having a meaningful probability of winning, no matter how much Bitcoin I'm spending. So, and I can actually share, we did a report on this last year on how we think about the security of stacks mining. But if someone was to, let's say, try to do something like a 51% attack on the stacks network by outmining everyone, and you would have to spend enough that you would get functionally a 100% chance of winning a stacks block. That in and of itself is extremely difficult to do, and would be, in order to do that without anyone noticing, it would be as difficult as creating a private Bitcoin fork of Bitcoin. The reason for this, again, is it's the last 6 blocks of spend that we look at. And so the entire network is going to see someone preparing for this attack well before they're actually able to pull anything off and reach anything close to 100%. Miners can raise their spend even marginally to kind of thwart this. There's a number of other ways that kind of attack can be thwarted as well. Getting back to the presentation though. Yeah, this just kind of provides a slightly deeper view of stacking in terms of how it actually works, and the proof of transfer contract and how it interacts with the stacking contract. We've gone through most of this, but this kind of shows how it is a permissionless forwarding of Bitcoin from miners to stackers. There's no middleman or entity facilitating that. It is a purely on-chain mechanism. And just to kind of go back and compare this to some of the other consensus mechanism types, again, proof of work is really the only consensus mechanism I've seen evidence and believe, really works in terms of providing again, the purpose of a blockchain and a blockchain-based network, which is Byzantine fault-tolerant consensus. Proof of work, consumes electricity specifically. Proof of stake, I think we're all familiar with, but you're locking up an economic stake in the network, and that is the basis of which you earn the right to mint units of the same cryptocurrency or whatever the asset of that network is. My problem with that is that's how the world today functions. It over time does not lead to a world where a network where you can independently come and verify the state of the network and participate in that consensus as kind of a new participant. Now, proof of burn and then proof of transfer are kind of two other modifications. Proof of transfer is actually a modification of proof of burn. Proof of burn is where miners, just like proof of transfer, spend a base cryptocurrency. So in the case of Stacks, if Stacks was proof of burn, miners, instead of forwarding Stacks tokens on to stackers, they would actually send that Bitcoin to an unrecoverable address. They would destroy it for the chance to mint the next Stacks block. The rest of it would kind of be the same as proof of transfer. The aha moment we had with proof of transfer is, you don't actually need to destroy that. You can actually forward it on to participants on the new network. But as I've mentioned before, proof of transfer is functionally equivalent to proof of work, and it's the miners themselves that are securing the network. So if the stacking part of proof of transfer were to break down for some reason, or cause issues in terms of economic centralization in the long term, the Stacks network just reverts to a proof of burn model. Getting a little deeper into kind of the difference here, this kind of gets into what is kind of the purpose of a blockchain. And we have this view that blockchains are they should not be used. They're neither general purpose databases nor general purpose computers, and they shouldn't be used as such. A blockchain is just a specific type of schema for a database. And in fact, it is arguably one of the most inefficient types of databases and schemas we've ever come up with. And as such, you really want to use it just for the purposes that you kind of need it to. So instead of putting everything on chain, the Stacks network kind of keeps that to what is needed to maintain that confirmation and BFT consensus from the Stacks network or derivative networks built on top of the Stacks network, ultimately down to Bitcoin. Some benefits of the kind of Stacks approach is, one, it doesn't change Bitcoin. It enables all of this without actually changing anything about Bitcoin, which for me is super important. The only reason I'm here and the only reason I started working on Stacks was because of Bitcoin. I think in a lot of our cases, Bitcoin is what kind of brought us into the space. And so having something that can leverage the security of Bitcoin, but without changing the Bitcoin network itself is kind of extremely important. Especially being able to enable Web3 on top of Bitcoin and have solutions for scaling transactions largely that can still do that is super important. In terms of the scalability solutions, hyperchains and app chains are the kind of keys there to take the composability that Stacks creates on top of Bitcoin and scale it in terms of transaction throughput. And as kind of the last bullet gets to, and what I was just speaking to, just how Stacks is kind of anchored to Bitcoin. Stacks enables anyone else to create a network on top of Stacks in the same way that Stacks is on top of Bitcoin. So instead, you can create a network where miners spend Stacks to mint whatever the new digital asset is of that network for whatever that specific use case is. That then settles down to the Stacks network, which settles down to the Bitcoin network. This kind of view is why the phrase "turtles all the way down" is one that's been one in the stack space for quite a while. If anyone is kind of familiar with the Hindu kind of myth there. And, I mean, for what it's worth, when you go back to the white paper, I don't necessarily, I'm not necessarily the biggest fan of the kind of Jesus Satoshi worship, but I will say the original Bitcoin white paper, in my opinion, at least, had this sort of idea in mind in terms of how you can kind of create separate networks that share CPU or security with Bitcoin in some way, and yet enable different use cases. So I think we have time for a bunch of questions, and I see a bunch. So I want to start going through these. So I'm just going to start from most recent and go back. So Alex G, is Stacks currently the only blockchain applying Web3 to Bitcoin, or are there others? If there are others doing the same as Stacks, why use Stacks? Great question. So there's a handful. Given kind of how the space has evolved pretty rapidly over the last few months, I'm expecting a lot more experimentation here. But right now, there's kind of two other. Stacks is the only project I've seen taking this approach in terms of this novel consensus mechanism and how that enables the network to settle down to Bitcoin. There are other approaches. Sovereign and RSK are kind of two that the two loose kind of camps in terms of like structure and ways of thinking are two-way peg, sidechain kind of networks, and federated networks. So in terms of federated, it's Liquid network is a great example of that. That's run by Adam Buck and the Blockstream team. Their view is, if you use Bitcoin for trust, you don't need as much trust in the network above. And for that, they don't, I believe they don't necessarily have a separate asset on that network. That's an incentive mechanism in terms of for mining. But instead, there are dedicated validators, if you will, and there's a trusted set of those that validate that network that then can settle to Bitcoin. So the trade-off they make, and it's one I think is an important one, and one that personally I'm not willing to compromise on, is that they have created a network that can settle down to Bitcoin, but it is not open participation or permissionless to participate in the validation of the consensus of that network. The two-way peg system, I'll kind of give my best run through of my understanding, but there's definitely some better people in the ecosystem, such as Jude or certainly Manib, who can kind of talk to the trade-offs there. But essentially there, what you're doing, it's kind of a little more similar to bridging assets, where you have there's no new asset introduced here. You can bridge, you can basically bring Bitcoin over to a new network where you can then do things like expressive smart contracts with it and kind of similar. The problem there and the issue that's never really been solved is to bring that Bitcoin back, or those transactions back, and have them ultimately settle on Stacks. The system relies on essentially an oracle structure. And so you end up, again, in a more trusted intermediary riddled kind of consensus mechanism and structure for that. The reason I personally like Stacks is, it accomplishes the goal that all three of these camps are going for, but in a way that remains open membership and permissionless for anyone to participate in. Let's get to a couple of the other questions. Okay, so quickly, how Stacks solves slowness in terms of TPS of the Bitcoin chain? So Stacks, the Stacks network itself doesn't really take on the challenge of scalability. Microblocks aren't really a scalability solution. They provide slightly faster initial transaction processing, but that's about it. The goal of the Stacks network in and of itself is to enable composability that can settle down to Bitcoin, and to enable networks on top of Stacks that can then take care of the transaction scalability, depending on what the use case is. One thing to remember about scalability is if you're kind of making that trade-off on a network-wide level, that may be needed for certain use cases, but isn't needed at all for others. The way Stacks solves this is via two different types of derivative networks on top of Stacks called hyperchains or app chains. An app chain is essentially the same as the Stacks network. It's what I described earlier. It uses proof of transfer, but on top of Stacks. So spend Stacks to compete to mine on that network, which then settles down to Stacks, which then settles down to Bitcoin. And depending on the use case, you can have these derivative networks can be their own full unique developer and kind of user experience. So if you need a very high TPS, if you have a use case that requires very high kind of transaction throughput, you can create a network that kind of enables that. Yep. So yeah, went over there are some other Web3 blockchain projects that are looking at doing similar stuff. RSK, Liquid, they all make different trade-offs in terms of how they do that. Again, Stacks is the one that, me personally kind of maintains what's most important in terms of the purpose of these open kind of decentralized networks. So with proof of transfer on Stacks, we're going the Bitcoin spent to bet on the Stacks block mini, Stacker 1 to Stacker 2, or not sure I understand the question. Sorry, Luca. But Bitcoin miners are not necessarily betting on Stacks block minting. They're making a rational economic calculation. Something that I should have mentioned earlier, but is worth mentioning now is, a question that I've certainly gotten a lot is, why would someone spend Bitcoin to mint Stacks tokens? Again, I consider myself kind of a pragmatic Bitcoin maximalist. And what I mean by that is, I'm here again because of Bitcoin, and it's what I kind of consider the king and the foundation of wealth and everything in this space. Essentially, yeah, sorry, I lost my train of thought there for a second. But yeah, for me, that's really kind of why I started here. And so with the Stacks network, I think it does a great job of extending that functionality while kind of maintaining the open and kind of permissionless part. Sorry about the loss of train of thought. This is the time of day where the jet lag starts to hit me pretty hard. Let's keep going with questions. So when the Bitcoin goes back into the network, is that then used to improve the network, or where does the funds go and what is it used for? Great question. So the Bitcoin goes specifically to Stacks token holders who are locking up their tokens and helping keep miners honest. So, sure, you can think of that as individual stackers. And, I certainly recommend, taking a look and maybe even engaging in an activity. I found it to be quite a powerful personal aha moment for, participation. But the holder entity that is locking up those Stacks tokens and stacking doesn't have to be an individual. And that's where stacking becomes a very interesting funding mechanism for funding things in Bitcoin. So I'll give you an example. One idea that I've had and that we might pursue later this year, and it's using the same kind of idea behind city coins, but it's this idea of stacking for a cause. So one of the things we've thought about doing is creating a DAO or some type of kind of community-owned entity where anyone can contribute Stacks tokens to. Those Stacks tokens are collectively put into a pool and they're stacked. And that pool, at any point, someone can maybe withdraw their Stacks, or certainly, at the end of a cycle, if they want to, they can withdraw them. But over time, that pool of stacks is generating Bitcoin. And that Bitcoin can be directed at different purposes. It can certainly, as the question asks, be directed at improving the network. It can also be directed, and this is kind of the idea I've had and one we might pursue, is creating this sort of entity where the Bitcoin is directed to funding Bitcoin development. One of the things that I would love to kind of see improved and would love to kind of play a part in improving is increasing the kind of funding options and therefore the amount of people that are actually actively developing and maintaining on top of Bitcoin. Right now, that is a bit of a tragedy of the commons type problem where everyone uses Bitcoin, they love the network, it's very valuable, yet it's really hard for Bitcoin core developers to get funding or, paid more than, a penance for the work they're doing on the network. You can create kind of an entity like this that specifically goes to incentivizing more of the top developers in the world to spend their time on Bitcoin, as well as bolstering the funding for core developers as is. That's just one example, but it's one where I think it shows kind of the interesting and unique funding primitive that kind of stacking can provide. Let's see, next question, Francisco. In Bitcoin, nodes can keep miners in check by choosing which blocks they accept or reject. It seems like in stacks, the holders of stacks take the place of the node holders. Do stacks holders have the same type of power? So no, they don't. Again, stacking is a nice to have in the consensus mechanism. Stacks, the way the stacks network functions in terms of security and confirmation is the same as a proof of work where node runners ultimately can, upgrade or not upgrade to new software. But I don't, this is worth double checking with someone who is a bit deeper than I am on a little more the technical side of the Bitcoin network. But my understanding is that those that are running a Bitcoin node can't really choose which blocks they accept or reject. That's not how that works. Ultimately, on the Bitcoin network, if you have a majority of miner, or if you have a majority pushing something and you have kind of agreement on the longest chain, that's kind of what, you could reject that as a node runner, but then you're potentially on a fork or something like that. Again, good question. Sorry, I'm not the kind of perfect person to get into the nuance, but the one thing I will say is Stacks token holders do not have that sort of power. Are there non-miner full nodes that participate in Stacks consensus analogous to full nodes? And yes, there are. So running a Stacks node doesn't necessarily mean you're mining. The reason you would run a Stacks node if you're not mining is you want to independently verify the global state of the network. Let's see. How does stacking incentivizes miners to build on the longest chain? What does that incentive mechanism look like? I.e. stacking self-sovereign. Yeah, that's one. You can maybe think of it that way. So, sorry, 1 second. Sorry, I think it's they're trying to clean the room in the hotel I'm in. So essentially, when stackers signal support for the longest chain tip, what they're doing is they're similar to, I guess, how a node can. Again, they don't determine this at all, but they're creating a global discovery mechanism for the network for what they believe, and ultimately what the majority of the network, or certainly those who are stacking, believe is the longest chain tip. So in the case of contentious forks, you basically, stackers are just providing a disincentive to try to create a contentious malicious fork, because if the majority of stackers can see that, you would, in addition to kind of co-opting some amount of miners to create that with you or doing it yourself on the mining side, you would also have the entire stacking side that would be pointing and saying, no, this is crap. This is actually the longest chain. It's a high level kind of explanation, but I hope that helps clarify a little bit. So if a malicious miner successfully attacks the network with a 51% attack, just for the sake of an example, if nobody follows, validates that miner's chain, e.g. users and builders do not want to follow the malicious miner, can the chain still survive, and how? A fork? Yeah, no different than any other blockchain-based network. Look back at what's happened with Bitcoin, Bitcoin Cash, Bitcoin Gold, BSV, whatever other crap you want to mention. Yeah, those ultimately are not the Bitcoin network, even though the creators of them tried to make them the Bitcoin network, because nobody followed that fork or that the changes that were pushed to that network. When it comes to a 51% attack, it's a little different, because that's not really the case of a contentious fork. That's the case of the majority of miners, or a single person that has a majority of mining power, validating a certain history of the chain. And Stacks is no different than Bitcoin there. Ultimately, that's what distributed consensus means. If the majority of the network agrees on something, then that's the truth for the network. This is why it's really important to be able to prevent a 51% attack. Okay. So if Stacks doesn't provide scalability in terms of transactions per second, would the system work in a real world scenario where people is actually using the network at a massive scale? Let's assume we develop a system that uses Stacks, requires quick transactions. Would that ever work? Yeah. So, again, it's about, there's kind of two things here. Stacks provides composability. And then if you need a high TPS use case on top of that, the whole world can be using potentially applications on top of Stacks if they don't need a high level of transaction throughput. If you're fine to wait 10 minutes for the block confirmation, depending on what the use case is there, that can be fine. For a lot of DeFi things, so for instance, a decentralized exchange, that is something where you're going to want quicker confirmation. For that, you can use a hyperchain or an app chain. And so for a real world example of this is Alex, the DeFi protocol on top of Stacks, is in the process of migrating to an app chain because they want quicker confirmation than the 10-minute block times. They want to enable people to, for instance, swap or take out a loan on Alex and have it confirm and have that go through on the end user side much quicker than 10 minutes, or certainly waiting for finality of kind of 6 blocks. First thought that people have when they think of mining is very, very large investments. So what is the starting point for anyone who's looking into being a part of mining? Great question. We'll be getting into a lot of this on the monthly Stacks Miner call coming up in 10 minutes. But that's why one of the things that my company, Demon, is working a lot on is enabling Stacks mining pools by the end of this year. Now, the key there, and the reason we haven't done this yet, is we're waiting for some of the upgrades in Clarity to be released, which will be included in the 2.1 upgrade, specifically the ability for Clarity to control taproot addresses. Because right now, if we wanted to create a pool, we could do one where, everyone basically just pools Bitcoin together, and then we use the Bitcoin to mine, or whoever's operating that pool uses the Bitcoin to mine. But that doesn't actually improve the security or the decentralization of the Stacks network at all. We're just still one miner, and it's more just a crowdfunding a single miner instead of really a mining pool. After the 2.1 upgrade, and again, if anyone's available and interested in digging into this, Jude and I will be getting pretty deep on this on the next call. But once 2.1 is kind of released, what that'll enable is it'll enable pools where participants are pooling together capital in the form of Bitcoin just on the Bitcoin network layer. But then on the Stacks network layer, they're all kind of collaboratively able to use that underlying pooled capital to individually compete to mine. And this is really important and really the goal we're going for, hopefully again by kind of the end of the year. Because in that scenario, people are pooling capital together, but then they're independently mining. And so that actually does add to the number of miners and kind of the decentralization and accessibility of mining. Cool, Luca, extending from previous question, we have Miami coins. What is an example use case that has actually worked? I am not involved in Miami coins at all. I don't hold any Miami coin. So not the best person to answer that. The 2 cents I will give for Miami coin and just city coins in general is, one, it's really early in terms of the evolution there and the utility. And I think there needs to be a lot of work done to kind of increase the utility of the Miami coin asset, because the city coins as an asset is really just an incentive mechanism in my eyes to provide a open community way for the kind of underlying Bitcoin funds to be used. So my understanding there, essentially is anyone can compete to mine Miami coin, same in a similar fashion as Stacks mining. You spend Stacks for the chance to mint Miami coin. Those Stacks are put into a pool, which generates Bitcoin, and that Bitcoin goes into a wallet held by the city. The most obvious utility for the Miami coin is holders of Miami coin long-term, I think maybe should be able to have some say in what those funds go towards. Again, though, I'm not involved with that project at all. That's just kind of my 2 cents on it. But yeah, definitely recommend reaching out to kind of the teams focused there. I know this is a Miami coin kind of developer camp, but that's how I would kind of think of that. Let's see. Have time for kind of a few more questions, and then I have to hop over to the monthly Stacks mining call. So for app chains, hyperchains, are smart contracts on one hyperchain composable with contracts on another hyperchain? As I understand, each separate hyperchain has their own separate blockchain, block production. So yes, they would. If they both use Clarity, then they should be composable across one another. But even if they're not, they're ultimately going to settle down to the same underlying network. And so you can use that to, for instance, enable app chains to work together kind of across different app chains. Again, hyperchains, not as sure as that's, hyperchains are more still under development, mainly by Hero. But with app chains, for instance, something I've talked to with Jude is, you can kind of create a DEX on top of Stacks using app chains, where each app chain deals with a different asset. And then you have a network between those app chains that enables the decentralized swapping of those across different app chains. Let me see. So that decentralized pool function you were talking about just now, you want to achieve by end of the year, is this functional available in Bitcoin mining? So I'm not sure if you mean by like for actual Bitcoin mining with pooling electricity, and I think it's a slightly different structure and paradigm, just because the overhead and kind of requirements, that the barrier to entry for Bitcoin mining is a little different. It's not just capital amount. But yeah, I mean, there are some, that does, a functional equivalent of that, to my understanding, does exist on top of Bitcoin, where you have some, a lot of the pools that exist as Bitcoin mining pools, essentially, they control huge Bitcoin, it's basically people pooling together hash power. So access to electricity or CPU power in order to, all collectively compete to mine Bitcoin. It's a yeah, it's a slightly different paradigm though, I think, on the Bitcoin level. Let's see. Yeah, I think that's most of the questions for now. I think there is some good discussion happening back and forth, though. I can see in the comments about kind of Miami coin specifically. One thing I would say, because I do pretty much have to hop off to do the monthly Stacks Miner call, but first of all, thank you all for coming and sitting and listening. I hope this was valuable. Thank you to the organizers for kind of having me on. More than happy to kind of come back in the future and do more of these. If anyone does have questions or wants to dive deeper into anything we talked about, give me a follow on Twitter. My DMs, for better or worse, are open. That is my Twitter handle. And then, yeah, super quick, let me share a link. Give me one moment, folks, to the mining call that is coming up. Here we go. That should work. Awesome. Thank you, everyone. This was a blast.
Thank you, Zan. This was great. Hopefully very resourceful to a lot of students here. And hopefully we would see a couple of people joining you on your monthly miner call as well.
Yeah, Jude and I think, have a bunch of stuff to chat through for about the first half, but if folks do join, we'll try to open it up to, oh, whoops, I realized I'm DMing instead of everyone. Apologies. So 1 second. This is my Twitter, and that's the event link. But yeah, we should hopefully have some time for Q&A at the end of it, if anyone does join. But awesome. Thanks, everyone.
Thank you, Zan. My audience, I see you people are very excited about Miami Coin. So tomorrow in our session, we will be talking about city coins. You can post a lot of questions and have your queries clarified about city coins and the projects around that tomorrow. We'll have Andre and Patrick meeting you guys, and see you tomorrow at 5 p.m. EST. And also to mention, we would be sharing a couple more resources on the Stacks blockchain and details and resources of what Zan was talking about. And if you want, we can email you, but we would definitely be sharing that on our Discord channel. So look out for those announcements. Thank you all. See you tomorrow, and thank you for joining.
Thank you, everybody.